Welcome to one of my favorite topics, hypothesis testing. For those that are doing business statistics or quantitative techniques, or people that want to venture into quantitative research, this is one of those topics that you might be interested in. So what is hypothesis testing? Hypothesis testing looks at gathering data and analyzing it so that one can determine whether a claim is true or false. There are different types of hypothesis tests. Tests involving a single population parameter are called one sample test. For example, we have a single mean or a single proportion. Then when we look at tests involving populations that are more than one, for example 2, we have the difference of 2 means and the difference of 2 proportions. Then we also have patterns of outcomes. That's the chi-squared test. And lastly, we have ANOVA, which is analysis of variance. Let's look at the steps that you take when you're doing hypothesis testing. Obviously, you would need some information for you to be able to do hypothesis testing. You would need your mu, you would need your significance level, which is the alpha, standard deviation, where you need n, which is the number in the sample, and then you need your mean. So the first step is to formulate the null hypothesis and the alternative hypothesis. Null, that's H0, alternative, that's H1. Secondly, you need to determine the region of rejection. I urge you to draw the curve. Do not proceed without drawing the normal distribution curve. Step number 3, you formulate the decision rule using the critical value. So remember, from our normal distribution probability, you had to look for critical values in the normal Z table. Then after that, you do the calculation of the sample test statistic. That can be the Z calc or the T calc or the chi-squared calc. Okay, it just means calculated. Then after that, you compare the sample test statistic to the region of acceptance. Remember your decision rule that you would have made in step number 3. Then lastly, which is step number 6, you draw statistical and management conclusion. With your decision rule, you will be able to either reject the null hypothesis, or you will not be able to reject the null hypothesis. And then you would accept a claim whether it's true, or reject a claim because it's false. Then draw the management conclusion. So those are the steps. Let's get to an example where you will be able to formulate a hypothesis from a question. So H0, that's your null hypothesis. It always contains the equal sign, okay, or an equivalent sign. So we have an equal sign, we have less or equal, or greater or equal. Then the alternative hypothesis, which is the complement, the opposite. So if you have an equal sign, then you have an unequal sign for your alternative hypothesis. If you have a less or equal sign, then you will have a greater than sign. Then lastly, if you have a greater or equal sign in your null hypothesis, then it means the opposite of it is the less than. So you just turn it around. Let's look at an example. If a question says the mean savings per student is 750, which means it's equal. So the claim is in the null hypothesis. They are saying that mu is equals to 750. That is how you would write it. And then the opposite of equal is not equal. These are easy marks in an exam. Always start with your null hypothesis and then your alternative hypothesis. Let's look at the second example. The mean savings per student average is less than 750, less than, which actually means that the claim is in the alternative hypothesis, because in the alternative hypothesis you have less than or greater than or not equal. All right. So the opposite of less than is greater than. Okay. Alright, so this is how you would actually write it. Always remember that your null hypothesis has an equivalent sign. Alright, now step number 2. In step number 2, you will be able to determine the region of rejection. You have to draw the curve. If I just show you here very quickly, when we have a null hypothesis that has an equal sign, it means that there are two areas of rejection. So it's on the far left and on the far right. Then when you look at less than, in the alternative hypothesis, it means that the rejection area is in the negative, so it's the less side. Another way in which you know where to put the rejection area is where the arrow is pointing. Here I'm talking specifically about the alternative hypothesis. So if the alternative hypothesis is facing this direction, then it means that is the rejection area. If you look at this, it is saying mu is greater than 750, which actually means that we are looking at the positive side, the bigger side. Okay, and you can also see the arrow is pointing this direction. All right. After doing that, the next thing that you need to do is to formulate the decision rule. Now, always start your decision rule by saying reject H0 if da 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 da. Okay, that's how you would start your decision rule. Now, let's look at this question. When we look at the question, it says, a banker claims that on average students save more than 750 per year. Test the claim at 5% significance level. If a sample of 45 students saved 745 per year. Okay, now I need my critical value. My significance level is 5%, which is 0.05. Then the easiest way is to look at the t-table. When I look at the t-table, I go at the last row. That is where my Z values are. So I'll go at the T table, look for 5% and go down. The value that I'm looking for is 1.645. That's the critical value. All right, it's here. All right, that will determine my rejection area. Now, what I am then going to say is this. Because I'm looking at greater than, which means on the positive side, this is the rejection area. If I find a value around this side, then I'm going to reject it. So if you read my decision rule, it says reject H0 if Z calculated is greater than 1.645. Anything greater than this, I will reject it. But anything less than that, I will not reject it. All right. So that is where my rejection zone is. Now, step number 4 says calculate the sample test statistic. We have our formula there. You are familiar with that formula. All you need to do is to substitute. We have our values. We have a mean of 745, standard deviation 135, right? N is equals to 45. You put that in your calculator and you're going to get minus 0.2485. Okay, that's step number 4. You will then use this test statistic to compare it to the decision rule. Now let's look at comparison of the sample test statistic to the region of acceptance. Remember from the previous slide, we were saying reject H0 if Z calculated is greater than if it is this side. All right, but we have found out that ours is less than that because it's a negative, it's this side, which means it's in the do not reject area. So what are we saying? We are saying that our Z calculated is minus 0.2485 is less than 1.645. Therefore, do not reject H0. All right. Just to give you a hint here, what you need to do is to find out if something falls into the rejection area or in the do not rejection area. That's the first thing that you need to do. So if your test statistic falls in the rejection area, which is this one, then you reject H0. So when you reject H0, it means you have to accept the alternative, which is H1. Then H1 is true. But if you do not reject H0, which is in this side, or you fail to reject H0, it means then that H0 is true. Cool. All right. So as I have just alluded to earlier, minus 0.2485 is found in the do not reject area. We will never say accept H0. It's either you are rejecting H0 or you are failing to reject H0. Okay, cool. Then the last thing that you do is to draw a statistical and management conclusion. The best way to do it is to always look at the question. You need to recognize what the claim is. Is the claim in the H0 or is it in the H1? and you also need to mention the significant level. So this is how you would do it. Now that we are not rejecting H naught, our conclusion is we do not reject H naught at alpha is equals to 0.05. That's our significant level. You always mention the significant level. And conclude that the banker's claim is probably false. Okay, because here we are not rejecting H naught, which means H naught is true, and probably H alternative is false. Now, I want you to practice these questions on your own. The one is less than, and the other one is for equal. You need to pause the video and try this on your own. In my next video, I will be solving these two questions, so it will always be preferable if you can do them on your own, so that once I've done the video, you can then check your answers. Take care.